All right, so just a couple left here. It says, which is bigger, 5 to the negative 2 or 2 to the negative 4? Explain your answer. Well, so let's take a look at what a negative exponent even means. I think a really easy kind of proof of what's happening is that, let's take that 5 to the negative 2, for instance, is that if I had, let's say I made a little table here, and I said, well, what's 5 to the positive 2? Well, 5 to the positive 2 means 5 times 5, which is 25. If I said, well, let's count down then. So 5 to the first just would be 5. And then I said, well, okay, so then what would 5 to the 0 be? Well, to figure out that, you might think it's 0 because you see the 0. But let's look at the pattern. How did we get from 25 to 5? Well, we divided by 5. So what if we kept dividing by 5? Well, 5 divided by 5 would be 1. And then let's say, well, what if it's a negative, right? What if the exponent's a negative? Because I keep counting down to 1, 0, negative 1. Well, keep dividing by 5. 25 divided by 5 is 5. Divided by 5 is 1. If I divide by 5 again, I get a fraction. I get 1 over 5. And then 5 to the negative 2, what if I divide that by 5 again? I get 1 over 25. So notice what happened is that it's 5 to the positive 2 is 25. 5 to the negative 2 is 1 over 25. So the number is the same. The only difference is it's a fraction, right? And it's a fraction with 1 on top. So that's what this is up here to kind of remind you of, is that a negative exponent is really just a fraction, right? We've taken the reciprocal. So if I wanted to know what 2 to the negative 4 is, and I don't have to make the whole table on this, but if I said, well, what's 2 to the positive 4? Well, that means 2 times 2, which is 4, times 8, or times another 2, which is 8, times another 2, which is 16. 2 cubed means 2 times 2 times 2, which is 8. 2 squared, 2 times 2, which is 4. 2 to the first, which is 2. 2 to the 0, and they're like, oh, what is 2 to the 0? Well, again, notice what's happening. It's being divided by 2, or maybe another way to say that is being cut in half. Well, half of 2 is 1. So one thing we notice here is that anything to the 0 power is equal to 1. Let's dip down into the negatives. So if I kept dividing by 2, I would get 1/2. If I divided, so half of a half is a quarter, right? And then I'm going to keep dividing by 2. So 2 to the negative 3 would be 1/8, and then 2 to the negative 4 would be 1 over 16, not 16, 1 over 16. So notice what happens is that 2 to the positive 4 is 16, so 2 to the negative 4 is just 1 over 16. So let's kind of summarize this. 5 to the negative 2, and all of this was to help us figure out which one's bigger, really means 1 over 5 squared, which would be 1 over 25. One thing we say with negative exponents, turn that frown upside down. So frown, we mean negative. Smile means positive, right? And then upside down means we're taking the reciprocal. We're flipping it. So turn that frown upside down. 2 to the negative 4th is 1 over 16. And then if I wanted to, let's say I did this in the calculator, right? Because I could have done this in the calculator as well. If I said 1 divided by 25, if I made that a decimal, I get 0.04. And 1 over 16, let's do 1 divided by 16, is 0.0625. 0.0625. Well, 6 cents is more than 4 cents. So 2 to the negative 4th would be larger. Right? And what we could say there is that, again, thinking about money, is that 2 to the negative 4 is larger because it is closer to 1. Right? That's one way we could say that. And by the way, we could have just put that into the calculator from the very beginning. We could have said 5 raised the roof to the negative 2, and we get 0.04. And then 2 raised the roof to the negative 4, which we get 0.0625. So we were kind of showing it by fraction, and we could also say here too is that the number that with the smaller denominator, that ends up being a bigger number, right? Because you're not splitting it up into as many pieces, right? If you think about fractions being kind of pieces of a pie. Right? All right, so pause now and try kind of that same thinking, convert to a fraction, convert to a decimal, compare, and then use that to figure out which one's a number that's closer to 1.